Hello, everyone. Today we are beginning to talk about the graphs of exponential equations. So we've simplified exponents, we've worked with them. Now let's see how they'll look with all these different key attributes right here. Those are basically key features of this graph. So we have a few vocab words here to start with on this. Okay, so the first one here would be growth or decay. The equation is either getting bigger or smaller. To the left, underneath the words, I'm going to show you what it's generally going to look like. So growth, it's going to be a curved line going up. Decay would be a curved line going down. All right, next then, the domain. These are the x values. We've done this last semester. So this is left to right, if you want to draw that to help you remind yourself. Then range, that's your y values, or bottom to top, or something like this. So you can remind yourself, all right, left to right, bottom to top. Okay, then the y-intercept, that's where the graph crosses the y-axis. All right, and then the equation for the asymptote. So our asymptote in these problems are going to be this horizontal dotted line. I'm just drawing it underneath so you have an idea. Okay, so a horizontal line, that's either going to be a Hoy line or a Vux line. Hoy, that's horizontal, 0, y equals. Vux, that's vertical, undefined, or x equals. That's just a way we can remember it. So it's a horizontal line. So it's Hoy. That means it's going to be a y equals something. So it'll depend on the equation and the graph to help you figure out what that will be. So I'm going to write out what this is. It's a horizontal dotted line that the graph does not cross. Oops. Okay, now we have a couple fill in the blanks. All right, first one, a function is linear if the table of values has a common difference. Common difference means you add or subtract to get the next y value. Let me draw an example here. Okay, we've seen this table before. Last chapter, we'd say, okay, what's my slope? We said, okay, we're going up by 4 each time. Or went up by 1 on the left side. So I did 4 over 1. That was my slope. That was a linear equation. When I graphed it, it was a straight line. Now we're starting an exponential equation. So this next line here, okay, if it's exponential, instead of adding or subtracting like we have been, we are multiplying to get the next y value. So you're going to see down below in example 1 how that's going to look. Just a preview here. Instead of a straight line like we had before, it's going to either look like growth or decay. It's going to be a curved equation. All right, let's look at example 1. Identifying growth or decay from a table. Okay, so what we're going to do first is figure out what our common ratio. That's the number that we're multiplying by each time to get the next value. So I'm going to draw my little arrows here on the right side. I'll also draw on the left side because I'm going up by 1 each time, but sometimes, you never know. They could skip by 2. Okay, so to go from 64 to 16, we are getting smaller. So I'm multiplying by a number less than 1. Some of you might say, okay, I'm actually dividing by, if I did 64 divided by 16, that should be 4. So I'm dividing by 4. I'm not going to write dividing by 4 because I always want to write it as multiplying by something. So if I'm dividing by 4, think of, okay, that's the same as multiplying by 1/4. So I'm timesing by 1/4. Again, oops, let me write this in the middle, sorry. So times by 1/4. Then to go from 16 to 4, again, I'm multiplying by 1/4 or dividing by 4, same thing. I'm doing that exact same thing here again. So our common ratio is 1/4 or 0.25. There would be decaying. It's getting smaller. The numbers are decreasing as we move down the table. And then my y-intercept, that is when x equals 0. So it's this line here. So my y-intercept, that's when it crosses the y-axis, would be 0, 64. Okay, number 2 then, our common ratio. Draw my little arrows. I'm increasing by 1 each time on the left. On the right, I'm multiplying by 2. Nice job. So 2 each time. That's my common ratio. I'm growing. This number is greater than 1, so I'm getting bigger each time. And then my y-intercept is where my x is equal to 0, so it's 0, 8. Okay, number 3, there's some negatives, so this just takes a little bit of extra thought to make sure we're doing it correctly. So I'm increasing by 1 each time on this side. All right, now on the right side, I have -3 times something equals -9. So I actually just wrote a little equation here, didn't I? If I divide both sides by -3, x is equal to +3. Okay, so I'm multiplying by just a +3. Some of you may have thought, oh, I multiply by -3. But if I multiply by -3, this 9 here, where's my mouse? There it is, would be a positive then. It would alternate signs. It's not alternating signs, so I need to multiply just by a positive each time. Okay, so then 9 times +3 would give you -27. -27 times a +3 will give you a -81. All right, so that's my common ratio. I'm growing because the number is greater than 1. My y-intercept, 0, -9. Okay, example 2. Now we are figuring out if it's growth or decay from a rule or an equation. Same thing. Okay, first one here, my common ratio. That's the number that I'm multiplying each time. That's the number by the exponent. So in this case, that would be 0.25 because that's what's being, raised to the x, to the first, the second, to the third. If this number in the parentheses is greater than 1, it's growth. If it's less than 1, it's decay. So 0.25 is less than 1, so it's decaying. It's going to get smaller each time. If you want to check that, you can do 0.25 squared. It's an even smaller decimal. 0.25 to the third, even smaller. Okay, our y-intercept. This is when x equals 0. So I'm going to plug in 0 for x. So I have y equals 12 times 0.25 to the 0. This part here, anything to the 0 power we know is 1. So I have 12 times 1, y just equals 12. Okay, so y equals 12. That's when x is 0, so I'm going to write 0, 12. All right, number 2, my common ratio, that's the number by the exponent. That's 4. That's greater than 1, so that's growing. Then my y-intercept, that's when x equals 0. So I have y equals 3 times 4 to the 0. That's equal to 1. So I have 3 times 1. So y equals 3. If I write as a point, my y goes second. That's when x is 0. So my point, my y-intercept is 0, 3. If you've noticed, my y-intercept happens to be the number in front. It's 12 here, 3 here. That's because anything with the exponent is going to reduce to 1 when you plug in 0 for x. So just a little shortcut, if you've noticed that. Okay, example 3. Now we're looking at some equations that are already graphed for you. All right, first one here, this is our favorite one, growth or decay. If it's going up, that's getting bigger, so that is growth. Okay, my y-intercept then, that's where it hits the y-axis. That's this line here. So that point is 0, 1. All right, and then my domain, that's from left to right. If you notice on this equation, they're very tiny, but there's little arrows on both ends because it keeps going forever. So this is going forever left, and this is going forever right and up. It's just going to keep going. So my domain is negative infinity because it keeps going left forever. My right number here would be positive infinity because it keeps going this way on the x-axis. It's going to keep going, and up, but it still goes right as well. All right, my range, that's from bottom to top. I start here. Oh, this line is my bottom point. That's at the value of 0. So I can put a parenthesis around that because actually it's never going to actually touch 0. Then I'm going to go up, and it keeps going forever up. So I'm going to have 0 to infinity. So let's scroll back down here. Okay, then the last one here. My asymptote is this dotted horizontal line that I can draw that the graph is never going to touch. So if I draw a horizontal line here, and I'm able to zoom in really, really close in this area, this line is actually never going to touch it. It's going to keep getting as close as we possibly can, but never crossing this dotted line. That's why we can call this an asymptote. So the equation of this line, it's a horizontal line, so it's a y equals, and then the value is 0. Because if I look on this line here, this is -1, this is 1, so this value is 0. Okay. So next one here, we see that the graph is going down. It's decreasing, so that would be decay. My y-intercept is right here, so that would be 0, -1. My domain, it's going forever to the left. It keeps going like that, forever to the right, like that. So it'd be, again, negative infinity to positive infinity. With exponential equations, you're going to see this pattern of your domain. It's going to be all the values. All right, and then my range. If I look here, this is the arrow's not crossing this line. So I'm going to draw my asymptote right here because that'll help us with the range as well. If I start at this value, so that'd be -3, that's the start of my range. Put a parenthesis because it's not actually touching that number. And then it's going to keep going all the way up to positive infinity. Okay, then my asymptote, that's the horizontal line that I just drew in green. So that'd be y equals -3. Okay. Let's do these guys here. So we see, okay, growth, it's going up. My y-intercept is right here. That would be 0, 3. My domain, you can see it's going forever left and forever right. Okay, then my range. Let me draw my asymptote in here. So if I go up, I'm starting at +2 and going forever. So that's my range. Then my asymptote would be that y equals +2. Okay. And we're going to stop there for today. So good luck on your classwork.